Welcome to the session on trigonometry and modelling with trigonometric functions. The objectives for this session are to use trigonometric functions to model real-life situations. Sometimes the identities that you can see on your screen now can help with solving real-life situations. Pause the video and have a go at this example. Press play when you're ready to view the solutions. So let's take a look at part A first. The angle of displacement theta of a pendulum at time t seconds after release is modelled by the equation theta equals 0.05 cos 20t, where all angles are measured in radians. We are required to state the maximum displacement. So let's solve this. Since theta equals 0.05 cos 20t, we have that the maximum displacement is equal to 0.05 times 1, since the maximum value of cos is equal to 1. Therefore, the maximum displacement is equal to 0.05 radians. Now let's take a look at part B. In the same scenario, we are required to calculate the angle of the displacement of the pendulum after 0.3 seconds. So let's solve this. Again, we have that theta equals 0.05 cos 20t, and therefore the angle of displacement after 0.3 seconds is equal to 0.05 cos 20 times 0.3, where of course 0.3 has taken the place of t in the formula. And this is equal to 0.05 times cos 6, which is equal to 0.048 radians. Now let's take a look at part C. We are required to find the time it takes for the pendulum to return to its starting position. So let's solve this. At the starting point, in other words, when t is equal to 0, we have that theta equals 0.05 cos 20 times 0, which is equal to 0.05. And therefore, we are required to find the value of t when theta equals 0.05. And plugging this into our formula gives us that 0.05 cos 20t equals 0.05. And therefore, cos 20t equals 1. In other words, 20t equals 2 pi. And therefore, t is equal to pi over 10, which in decimals is 0.314 seconds. So the time it takes for the pendulum to return to its starting position is 0.314 seconds. Now let's take a look at part D. In the same scenario, we are required to find the times during the first 0.3 seconds of motion that the pendulum has displacement of 0.02 radians. So let's solve this. Again, in the formula for theta, when theta is equal to 0.02, we have that 0.02 equals 0.05 cos 20t. And so we're required to find t when cos 20t equals 0.4. Therefore, using inverse cos on our calculator gives us that 20t equals 1.159. We also have another solution because cos is positive, so the other solution is in the fourth quadrant. Therefore, 20t can also equal 2 pi minus 1.159. So 20t equals 1.159 or 5.124. Therefore, t is equal to 0.058 seconds or 0.256 seconds. This brings us to the end of this session. If you have understood its contents, you should be able to use trigonometric functions to model real-life situations. Thank you very much for listening. To understand this topic in greater depth, do attempt the exercises in your textbook related to this topic.